Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code P2243 references an issue found in the air-fuel ratio AF sensor, specifically identifying high voltage on the VCENT circuit associated with sensor 1. The AF sensor's role is to monitor the air-fuel mixture in the engine, enabling optimal combustion for efficiency and emissions control. It is crucial for the Engine Control Unit, ECU, or Powertrain Control Module, PCM, to receive accurate data from this sensor to adjust fuel delivery. When the AF sensor detects an open VCENT circuit, it signals a malfunction, leading the PCM to store the DTC P2243, indicating a distorted signal that requires attention. The sensor is typically located on the exhaust manifold, close to the engine, allowing it to gauge the exhaust gases effectively. This error needs to be diagnosed properly, as it can lead to poor engine performance and increased emissions if left unresolved. DTC P2243 indicates a malfunction in the air-fuel ratio sensor, identified as sensor 1. This sensor's primary role is to ascertain the optimal air-fuel mixture by monitoring exhaust gases, which directly impacts fuel efficiency and emissions. It is strategically positioned on the exhaust manifold, allowing it to effectively measure the composition of gases that exit the combustion chamber. When the VCENT circuit is flagged for high voltage, it signifies that there is either an open circuit or an issue within the sensor wiring or the sensor itself. This alert leads the Powertrain Control Module, PCM, to memorize the issue, prompting a closer examination of the components involved. A malfunctioning AF sensor can lead to compromised engine performance, making it crucial to address promptly. Several potential causes can lead to the occurrence of DTC P2243. Firstly, an open VCENT circuit is a common culprit, which could be due to damaged wiring or loose connectors interrupting the signal. Secondly, a malfunctioning Powertrain Control Module, PCM, may not interpret signals correctly, hence generating the error code. The PCM serves as the brain of the vehicle's engine management system, controlling operations based on input from various sensors, including the AF sensor. Lastly, the possibility of a defective AF sensor could be the root cause. If this sensor fails, it will not provide accurate readings to the PCM, subsequently impacting fuel mixture adjustments. Understanding these causes helps in determining the most efficient troubleshooting path. When diagnosing DTC P2243, you may observe several symptoms that indicate an issue with the AF sensor's functionality. One noticeable symptom is the illumination of the check engine light on the dashboard, signaling that the PCM has detected a fault. Secondly, poor fuel economy can arise as an outcome of incorrect air-fuel mixture adjustments, leading to excessive fuel consumption. Furthermore, drivers may experience rough engine performance characterized by uneven idling or stalling, making it difficult to maintain a steady speed. These symptoms result primarily from the PCM's inability to receive accurate data from the AF sensor. Identifying these signs early is vital for effective troubleshooting and resolution of the issue. The first step in troubleshooting DTC P2243 involves confirming the error through engine operation. Start the engine and maintain the engine speed at approximately 3,000 revolutions per minute, RPM, without any load, ensuring the vehicle is in park, P, or neutral, N. Holding this speed will allow the radiator fan to activate, which is a pivotal point indicating proper engine cooling functionality. After confirming that the fan has engaged, allow the engine to transition back to idle. This process helps in producing sufficient exhaust gases for the AF sensor to provide readings, supporting later evaluations of the sensor's output. Checking these initial parameters is critical before executing detailed inspections. For the second troubleshooting step, initiate by disconnecting the AF sensor, sensor 1, connector and the PCM connector E. This step is essential for ensuring that no false readings are taken during inspections. Once the connectors are detached, prepare to inspect the VCENT circuit for any signs of damage or disconnection. A direct circuit continuity check is crucial, specifically assessing the female terminals of both the AF sensor and PCM connector. It's important to examine whether the circuit exhibits less than 1 ohm of resistance, which indicates healthy wiring. If readings deviate, it signifies an issue within the circuit requiring further investigation and possible repairs. Maintaining circuit integrity is foundational in resolving DTC P2243 during step 3 of troubleshooting. It is necessary to reconnect the AF sensor while it's still disconnected from the PCM to perform a confirmation test. Begin this phase by executing the engine confirmation procedure again to establish a consistent test environment. From this point, check the output voltage of the unit while the engine is running, ensuring that the conditions simulate normal operational behavior. The expected output voltage should be around 0.2 volts or greater, which signals that the AF sensor is successfully sending valid data to the PCM. Should the output fall below this threshold, it often indicates a problem with the PCM itself or the AF sensor, requiring isolation of the malfunctioning component for replacement or repair. Faulty outputs can indicate systemic issues that can highly impact vehicle performance. In the final troubleshooting step, if previous inspections have confirmed that the circuit and PCM are functioning well, attention should turn to the AF sensor, sensor 1. This step is crucial, as it determines if the sensor itself is the root cause behind DTC P2243. Conduct a thorough inspection of the remaining AF circuit. If all aspects check out correctly and indicate healthy function, the AF sensor must be deemed defective. Completing this assessment may empower the technician to replace the faulty sensor with a new one, resolving the high voltage issue present in the VCENT circuit. Replacing the AF sensor based on positive identification is a vital conclusion in rectifying the diagnostic error, bringing the vehicle's air-fuel mixture readings back to optimal functionality. After repairing the faulty component related to DTC P2243, it's essential to perform a final verification. Begin this step by clearing any Diagnostic Trouble Codes, DTCs, from the vehicle's onboard diagnostic system. This action resets the engine control unit's computer, allowing it to recalibrate and reassess real-time data from the repaired sensor. Following this clearance, it's prudent to perform a test drive to evaluate the vehicle's performance, especially monitoring engine responsiveness and behavior under normal driving conditions. Instrument monitoring should be conducted post-test drive to check for any recurrence of the previously encountered DTC. Successful verification confirms that the repairs have effectively resolved the issue, reinstating the AF sensor's functionality smoothly. Preventive maintenance plays an invaluable role in mitigating future occurrences of DTC P2243 or similar sensor-related issues. Regular inspections of the AF sensor and associated circuits are vital to identify potential wear, damage, or corrosion. Maintaining clean and secure electrical connections drastically reduces the chances of open circuits and faulty signals reaching the PCM. Furthermore, routine monitoring of overall engine performance and fuel efficiency can help spot any deviations from expected behavior quickly. By integrating preventive measures into regular vehicle maintenance schedules, owners can proactively address issues before they escalate, ensuring optimal vehicle reliability and performance with minimal disruptions. In conclusion, Addressing DTC P2243 effectively involves understanding both its origins and implications for vehicle performance. The role of the AF sensor in managing air-fuel mixtures is critical, and its proper functioning significantly influences fuel efficiency and emissions. Following a structured troubleshooting approach allows technicians to systematically isolate the issue, from external wiring to the PCM and finally the sensor itself. Regular maintenance and timely inspections are key strategies in preventing such faults from becoming recurrent problems. Prioritizing these proactive measures not only enhances the longevity of the component, but also ensures the overall reliability of the Honda CR-V. Understanding and acting on DTC P2243 leads to a smoother and more efficient driving experience. Please like and subscribe to the channel. See you next time.